So example 6.4.2, is it normal? So one way to measure intelligence is with an IQ score. So table 6.4.2 contains 50 IQ scores. And we want to determine, again, if it's reasonable to assume that this sample came from a population that is normally distributed or not. So part A says to state the random variable. So again, we have quantitative data, so it's going to be the measurement for a randomly selected object. So in this case, we're looking at IQ score for a randomly selected person. Okay, they didn't give us any specifics about where this data was taken. So again, to check if it came from a population that's normally distributed, again, we're going to look at a histogram and then a modified box plot and a normal probability plot. And then again, we're going to make an educated guess based on what we've seen in those three graphs. So the first thing we're going to do is we're going to draw a histogram. So again, if we actually took the time to type those 50 data points into the TI-84, and again, we're just using Zoom 9 to let it pick an automatic bin width and where to start those bins at to get a general shape. Okay, in StatCrunch, again, we're going to just let it pick its own bin width also. Again, we can see that these two histograms do not look exactly the same because the calculator uses a slightly different formula for its automatic bin width than StatCrunch does. But again, in either case, they do look roughly bell-shaped. So again, the next step is to make a modified box plot to check for outliers. So on the TI-84, if we were to make a modified box plot, we notice that this modified box plot looks like a normal box plot. There are no dots off to the left or to the right, which means that there are no outliers in this data set. The same thing in StatCrunch. This is a modified box plot, but it looks like a box plot because there are no outliers in the data set. So in this case, the modified box plot shows no outliers for this data set. All right, so the final graph that we're going to make is a normal probability plot. So again, we can do that on the TI-84 if you entered those 50 data points, but again, they're already uploaded into StatCrunch. And so if we make a QQ plot, a normal probability plot looks fairly linear. Again, we're not looking for dot-to-dot perfect. We're just looking for, a scattering of pebbles along a linear path that stay pretty close to that linear path that's there. So part E asks us if it's reasonable to assume that this sample data came from a population that's normally distributed. So again, considering that the histogram looked roughly bell-shaped, there are no outliers, and the normal probability plot looks roughly linear. The conclusion is that it is reasonable to assume this sample data came from a normal population. Again, that's our educated guess based on what we saw in these three graphs. So again, if we're asked to check for the assumption about a normal population, if we're given data, we're being asked indirectly to make three graphs. Make a histogram, see if it's roughly bell-shaped, make a modified box plot to make sure there are no outliers, and make a normal probability plot to see if it's roughly linear.